like a reference, it's not a good entry-level teaching material. And of course, I go to conferences, real and virtual, and I try to explain a lot of stuff there. But some people ask me, why don't you build training material based on those classes? So I started the execution plan video training, an even larger project that will eventually be probably more than 24 hours of video training material. It's not there yet. I think I have now maybe 3 or 4 hours available. I don't know exactly how much, and it's constantly getting more, where I offer an in-depth training course on execution plans. The first block is for free. The rest is not. I spend so much time on it, I cannot afford to give it all away. But because I love everyone who comes to my sessions, I like to give some discount. So between now and August 31st of 2021, you can buy access to all my currently available training classes by using the code DataGeeksSFL. And I believe it's case sensitive, so make sure you have the upper and lowercase right. So, or alternatively, if you prefer an even higher discount, you have to wait a bit. But in September, I'm going to give a virtual training class, 2 times 4 hours of training on execution plans. And if you attend that training class, then I will give you a 20% discount on all my current and future material that will not expire. I will probably give the same training class again in the future when I'm selected to give it at other conferences, and that offer is always there. So if you can't make it to the Data Platform Virtual Summit, you can try it somewhere else. Okay, that's enough advertising. On SQLServerFast.com, I also have some other content like my blog, my articles, and resources. The resources section is where you can find the deck and the demo code I'm going to show you today. I have a link in the Discord, in the Discord channel for the Einstein room. But if you forget the link, you can just go to SQLServerFast.com and then in the menu, choose other presentations, presentation resources, and you will find the slide deck and the demo code there. And if you watch this later on YouTube, it may be a newer version of the slide deck because sometimes I improve my stuff and I always keep the last version there. I do a lot of other stuff and nobody really cares about that, except for one thing, my email and my Twitter. I can understand that not everything is clear. And if you have a question now, you can just type it in the chat and Evelyn will read it to me. But if you have a question later, I encourage you to reach out to me. I always love to teach people who want to learn. So mail me, tweet me if you are stuck with anything. If there's something you run into that isn't quite clear, just reach out to me. So we're going to talk about execution plans. And the things I want to talk about is, because this is a beginner level session, let's start by why do we care about execution plans at all? I hope that after that block, all of you really care and you want to know where to find them. So that's the next part. The most important part, of course, is how do you read them? Because even if you have seen them before, if you've never learned how to read them, it's not all obvious. So I'm going to spend quite some time on that. We're going to talk a bit about properties in the execution plan. And at the end of the session, I have prepared 2 examples, but based on my experience, I probably will have time for just one of the 2. So that's already setting expectations. I will probably not have time to walk in all details through the second example. But let's start with, why should we care about execution plans? And to understand why we should care about execution plans, I need to start with a bit of background on the difference between the traditional 3rd generation procedural languages and SQL, structured query language, so-called 4th generation language. So if you look at those traditional 3rd generation languages, it's a bit comparable to the way I look at my morning routine. And mind you, this is a pre-COVID example, so there is some travel and meeting people involved that I don't actually do anymore. But I'm going to stick with the same example because it works and people can relate to it. So the way I see my morning routine is, the alarm clock goes, I get out of bed, I go to the bathroom, I take a shower, I brush my teeth, I dry off, I get dressed, I go to the kitchen, I eat my breakfast, I drink a coffee, I go to the car, I drive to the office, and I start working. Now, you see that this is a step-by-step description of all the things I do. And that's similar to a third generation procedural language, which is a step-by-step description of what the computer should do. And similar to that description for me, or for the computer, I get to make choices in what order I do it. I could reverse some orders. I could decide to get dressed and then take a shower. In programming languages, we call that a bug because it doesn't result in the desired outcome. The program doesn't do what it is supposed to do. So that's a bad description, and I do not want that to be my morning routine. But there's also choices that don't affect the outcome, but might affect how effective it is. For instance, I could choose to brush my teeth before hopping into the shower or after, or I could take my toothbrush under the shower and brush teeth while showering to save a bit of time. I could choose to have a long, healthy, and cozy breakfast with my wife and then go to the car, but then I need to get up earlier. Or I can choose to prepare my breakfast in the evening and just grab it along and eat it in the car while I'm stuck in the traffic jam, so I can stay in bed for a bit longer. Those are choices that affect how effective everything is. They don't affect the outcome. It's still the same outcome that I am in the office. So in programming languages, we often deal with large collections because computers are good at doing the same thing over and over again. So often you see loops where the same process is repeated over and over. And that is where there are often very many possible variations in how exactly such a loop is coded. And that is then called an algorithm choice. How exactly do we process this? How exactly do we approach the task that this program has to do to try to be as effective as possible? It's the developer that chooses this and then step by step tells the computer, you should do this first, then that, so that you are effective and are fast where we want you to be. If the code runs slow, who are we going to blame? The developer, because the developer wrote the code. They apparently chose a wrong algorithm because it's slow, so they are the one who should fix it. We blame the developer, and the developer can solve the issue. All of this applies to traditional third generation languages, but SQL is different. So in SQL, structured query language, we have a so-called fourth generation language, and that language is called, it does not give a step-by-step description of what to do, it only describes the end result. So for my morning routine, the SQL version would be how my boss sees it. My boss might send me a WhatsApp message in the afternoon or in the evening. Hey Hugo, we have an important customer in the office tomorrow, so make sure you're in by 9 and dress appropriate. That's all she cares about. She doesn't care whether I spend half an hour having breakfast with my wife or whether I have a hasty breakfast in the car. She doesn't care whether I brush my teeth before or after the shower. She only cares about one thing, the final result, that I am in the office in 9, not wearing any offensive shirt like I might do if it's just the IT department. And that's what SQL is. In SQL, we describe the result and we don't care how the computer gets there. It's set-based. It's basically a logical idea of we pretend that everything can happen all at once. In a split second, everything happens at once. And that's how we describe the stuff. But in reality, the computer still only processes one element at a time. Okay, if you have 16 CPUs, it might do 16 elements at a time because that's parallelism, but it can never do all at once. Every CPU does one instruction at a time. So there has to be some translation from this all at once description that we provide in the SQL to a step at a time processing that the CPU can handle. And this is done by the query optimizer. The query optimizer is a sub-program within SQL Server that has the task of looking at your query, looking at a lot of other information it has available, and then trying to choose the best algorithms to quickly and fast, and most of all correct, process the request you ask. But here it's the query optimizer that chooses the algorithm. So if the algorithm choice is bad, if the results are correct but way too slow, who are we going to blame? The query no, we can't blame software. So the blame goes here to me. Yeah, I can tell my boss, hey, it's not my fault. The query optimizer chose a bad algorithm. You know what my boss will say? She says, I don't care. I hired you to fix that. And she's right, of course. She pays me to make sure that the database is fast enough. But I didn't pick the algorithm. So we have a small issue there. Before we go back to that issue, let's take one step back, because this is SQL as a generic description. SQL is a language that is not specifically for Microsoft SQL Server. It is part of NG standard for all relational databases. So let's move to our favorite database, Microsoft SQL Server, where the SQL dialect is called Transact SQL, or for short, T-SQL. In T-SQL, we don't have pure SQL, pure set-based queries. In T-SQL, we have a mixture of set-based queries and procedural code. So we have elements of third-generation languages and elements of fourth-generation programming. It means that the slowness might be caused by the algorithm we chose in our procedural code, or it might be caused by the optimizer choosing a bad algorithm for a set-based query. Now, if you have code that does, code that does a lot of procedural stuff, if you overdo the looping and the step-by-step, then most of the time, if you have bad performance, the reason is that you made that choice. SQL Server specifically, more than other relational databases, is optimized to do set-based code as fast as possible. So if you use a lot of procedural code where you do step-by-step and where you code your loops that do row by row, then SQL Server will almost always punish you with terrible performance. How do you fix that? Try to rewrite that procedural code as set-based code. So I'm not even going to say choose a better algorithm. I'm going to say choose no algorithm at all. Use fourth generation language. But what if a single query is slow? We have a single query, or perhaps we have procedural code, but the entire code runs for 10 minutes and 9 minutes and 59 seconds of that is in one query. Then it doesn't matter that there's 1 second for the rest of the code. The issue is in that query. So what are we going to do if a single query is slow? Like I said, optimizer picked the algorithm. And if it's slow, then the optimizer picked the wrong algorithm. We don't know what algorithm it chose. And that's where the execution plan comes in. Because by looking at the execution plan, you can see the algorithm that is chosen by the optimizer. Once you know what algorithm it chose, you can probably understand why it was slow in this case. If you understand why it's slow in this case, you might be able to understand what you can do to fix that. You might know, 1 second please, you might know how to feed the optimizer with better information or a better query so that it gives you a better algorithm, a better execution plan. And that's why we care. I wanted to finish that sentence. What was the question? Was there a question?
Yes, if you can zoom out a little bit because the screen is cut off.
Sorry, I'm not sure how to do that. Where is it cut off?
We can see from soft SQL Server. We can see set base query. I can't see the beginning.
That's terrible. Then the much too much information is lost. I have no clue how to fix that, so I'm just going to do the blunt thing.
Oh, someone else say they can actually see the entire screen.
Oh, so it's just settings for one person then.
Okay. So.
Okay. And I see that there's some chat going on, so people are helping each other. I hope this resolves it. Ooh.
Yeah, it's about this particular.
I thought I had just wasted 15 minutes of everyone's life.
No. It seemed like it's split in half. So.
Okay, good. Glad that got resolved.
I appreciate it. Thank you.
If there's no more questions, I'm going to continue.
Yes,
so
please.
Now we know why we care about execution plans. And if I have convinced all of you that we care, you want to find them. Now, finding execution plans is a broad thing, and there are two broad areas where you can understand that. One is you are a production DBA. You have a busy server, hundreds of people are using it, and people are complaining that the server is slow. Too many resources are being taken. Some things that use hundreds of queries take too much time, and people are complaining or whatever. You need to find which plans cause it on a server that does hundreds or thousands of things at the same time. This is a real problem for people who monitor and manage busy servers. There are solutions for that, and I have them on your screen here, but I'm not going to talk about that because they are not in scope for this session. This session is not targeted towards production DBAs who do that kind of stuff. This session is targeted for beginners. So at the end of the session, I will have a slide with resources. One of the resources is a book by Grant Fritchie that goes through all of these elements and a lot more. It's definitely a good read, and I'm going to recommend it. But all of the things you see on the screen right now are covered in Grant Fritchie's book. So if you have this issue, if this is something you need to learn, go and read that book. But we are going to talk about a specific query. So perhaps your production DBA has already found the problem plan. And he says, this query is running 1,000 times per minute. It's taking 10 milliseconds. It should be 2 milliseconds. Or you have a manager saying, I have a report here. That report takes 20 minutes. I don't want to wait 20 minutes for my report. I want it within a minute. Whatever the issue, you know the exact query. Perhaps you are a developer. Welcome in my session. I'm glad you're here. I want developers here. You wrote a query and you want to make sure it's fast before even deploying to production. Good for you. I'm happy that you want that. You know the query because you just wrote it and you want to verify the performance. So there's multiple cases where you know the query. You know that one query you are interested in, you want to see, is it fast enough? Can I make it faster? How do you find a plan for that specific query? And for that, we'll jump into a demo. So for the demos for this session, I use extremely weird stuff, completely not representative of reality. If I ever have someone at my desk coming with a query that literally calls a function called delay and asks me, why is this slow? I will laugh so hard that they will never dare ask me a question again. Obviously, this is, of course, just a demo. Let's assume it's not so obvious as it's here, and we actually need to investigate why this query is slow. So there are multiple ways, and I'm going to select the query so that what I do affects only the selected text and not the entire window. And one of them, and I'm going to zoom in now, is to use this button. And as you see, it's called Display Estimated Execution Plan. I don't like the term Estimated Execution Plan. Microsoft introduced it in their tools. I know that some of Microsoft staff also are not happy with the terms, but they have been in use for a long time. I don't think they will ever change, but I have stopped using them because the estimated execution plan doesn't exist. This is just the execution plan. I'll get back to that later, but for now, I'm going to click this button. And then you will see that a new tab opens, and in that tab you see a pretty picture. How to read it, how to interpret that is something I'll get back to later in the session. But for now, just trust me, this is the execution plan. By clicking this button, we got the execution plan from SQL Server. We got it immediately. No query was executed. So whether this query takes 10 seconds or 5 minutes to execute, I don't have to wait. I immediately get the execution plan because we only ask SQL Server, how are you going to execute this query? But we didn't ask SQL Server, now go execute it. That changes with a different button. So I'm now going to go to this button. I'll use a different button. So this is called Include Actual Execution Plan. And this button, if I click it, nothing happens except that it changes looks. It's a toggle button. Now it's enabled. If I click it again, it's disabled. And if I click it again, it's enabled. So we'll leave it enabled now. And I will zoom out again. If I enable the option include actual plan, and that's also a term I don't use. I call it the execution plan plus runtime statistics. As you see, nothing happened on the screen. I just enabled the toggle, but if I execute it, the query will run. And that will take some time. I think it's about 20 seconds or so. And oh, it's already done. Not 20 seconds, but 6. And now you will see that I have the results tab, of course, because I executed the query. But I also have a tab called execution plan. And if I click there, we see roughly the same picture as before. There are more numbers in the screen than when I use the so-called estimated execution plan. That's the runtime statistics that were added to the execution plan. That's why I call this the execution plan plus runtime statistics. But the downside was we had to wait 6 seconds until the execution plan plus runtime statistics appeared. And we had to wait for that because the execution plan plus runtime statistics is returned after the query finishes. 6 seconds is not a bad thing, but if I do this for a report that runs for 2 hours, I have to wait 2 hours before I can finally look at the execution plan. To help alleviate that problem a slight bit, Microsoft decided to add one more option, and this is only available in relatively new versions of SQL Server. That's this button called Include Live Query Statistics. This button is also a toggle, so if I click it, it just goes enabled and nothing else happened. But with this button enabled, if I run the query again, you will see that immediately a window opens with the execution plan and some numbers, and then you will see that the numbers start updating as the query is running until it is finally finished. And by the time it's finished, you will see that yet another tab opens because I still have the include actual execution plan option enabled, so the execution plan plus runtime statistics is also there. And these look the same, but in reality, the execution plan plus runtime statistics has more runtime statistics than the live query statistics. The live query statistics has a subset of the runtime statistics, but you see them right from the start, which can of course be beneficial if you have to tune the 2-hour query, because maybe after 5 minutes, you already see where the issue is, and then you don't have to wait for 2 hours. So let's recapture the 3 options. The first is to just ask for the execution plan. And if you want to be explicit and avoid confusion, you call it the execution plan only. You only ask for the plan, you don't ask for execution. The term estimated execution plan, like I said, is confusing because there is no estimation going on there. What happens is when you click that button, Management Studio tells SQL Server, here's a query. Go figure out how to execute it because I want to run it. The optimizer comes up with the execution plan, says, okay, here's your plan, now you can run it. And then the rest of the engine says, haha, fooled you, I'm not going to execute it at all, but now I have your plan. The optimizer doesn't know that you are not intending to execute it. The optimizer does not have 2 code paths, one for compile a plan for a query we won't execute and one for compile a plan for a query we will execute. It would be wasteful to have 2 different code paths when one will do. The query optimizer just has one task, look at the query, figure out how to execute it. And then we fooled the optimizer because we're not going to execute it. But the plan shown is how it will be executed. And yes, there are some rare exceptions. Those have to do with stuff that change between when the execution plan is compiled and when the query actually starts running. In those cases, there may be reasons that trigger a so-called recompile. That's what causes a change, but that doesn't mean that the original execution plan was wrong or that it was just an estimation. It just means that there was reason to rethink the plan at one stage. Then we looked at the execution plan plus runtime statistics, or for short, execution plan plus. And the other confusing name, actual execution plan. Actual and estimated does so much sound like the estimated is just a guess. I think I'm going to do it like that. And the actual execution plan might be different because now we really thought about it. That's simply not how Microsoft SQL Server works. Sorry. So if you run a query with this execution plan plus runtime statistics option enabled, we start the same way. We start the same way by telling the optimizer, here's a query, give me a plan. And the optimizer does the exact same thing as in the previous example, but now we will actually execute the query based on that execution plan after. And while that is happening, runtime statistics are measured and added to the plan so we can check them later. The plan shown is the same as the execution plan only. It's exactly the same, but with those runtime statistics added. And those runtime statistics can provide a lot of information to help you understand problems, to help you understand why your query is slow. So when possible, I always like to use the execution plan plus and not the execution plan only, because I simply have more information. But if that means I have to wait 2 hours, yeah, then I sometimes look at the execution plan only and try to make do with the limited information I have there. And then, as I said, the execution plan with live statistics or the live execution plan, or we again start with the optimizer compiling a plan. It's the same step in all 3 cases, but now we show that plan immediately, and then we start execution. And as the query is executing, Management Studio keeps pulling SQL Server saying, hey, what are the runtime stats now? Hey, what are the runtime stats now? And they keep being updated on your screen. It's not all the statistics that you have in an execution plan plus runtime statistics, but it's the most important statistics. So especially for long-running queries, it can be very useful if you are lucky enough that in the first 5 minutes you see the issue. Worst case scenario, you still have to wait the 2 hours because you don't see it. And that's why I tend to run in cases like this with both the live statistics and the execution plan plus options enabled, so that I also get the execution plan with the complete runtime statistics. Now there's a large table on your screen, and I'm not even going to hide my camera, so I know you can't read everything. You're not supposed to read everything now. This is for reference. I told you where you can download the slide deck. Just download it later, read it. There's a huge amount of information here. Going through it would take 10 minutes. I don't have 10 minutes. So this is for later use. How do we read execution plans? We really want to do that. Now, we have seen those pictures, but we want to understand what it means. So this is a very simple, very basic execution plan. And if you see an execution plan like this, you need to know what is what, and you need to know that there's basically 2 elements within the execution plan. One of these elements are the icons, the pretty pictures. Well, perhaps not pretty, but that's subjective. The icons. The icons are called operators. And operators are small programs that have a specific task, very specialized. They can do one thing only. They can do that very well. They cannot do anything else. Some of them have some variations in how they can do it, but they are still small programs with one specific task. And then the other element are the arrows connecting the icons. Those are the data flows that show how data flows from one operator to the other. And if you look at the actual source of the execution plan, because what we just saw in the demo is a pretty picture, but the real execution plan that SQL Server returns to Management Studio is an XML document. That XML document is not intended to be used by humans. Management Studio uses it to draw the picture you see on your screen now. And you can almost always just use this picture, but it's important to know that actual source is an XML document. And in that XML document, you will not see anything that represents these arrows. The arrows are not elements of the plan. They are a representation of how the operators interact with each other, which is encoded by how they are organized and where they are put within the XML. So let's look at those operators in more detail, those small programs with their specific task. Each of those has, if you look at the C# level or the C++ level, I don't even know in what language Microsoft coded this, has 3 functions. They can be called for 3 specific tasks, and all operators support those 3 tasks. The first is the initialize task. The initialize task is the first thing called on every operator. It says, hey, you need to prepare to do some work. So it might assign some memory, it might initialize some variables. It does whatever it needs to be prepared. Most of the times when an execution plan runs, every operator is initialized once. But sometimes operators are initialized multiple times. And if they're initialized a second time, it basically means restart from the top. We're just going to do it all over again. And sometimes it's actually doing the same thing over again. That might sound silly, but sometimes doing the same thing over again is the most effective way to get where you want to be. But sometimes there's also something in the input to that operator that causes it to change. Imagine an operator reading data from somewhere that has been filtered on the city. So if I use that to read everyone from San Francisco, I get a certain amount of data. If I then say initialize it again, but now not for San Francisco, but for Los Angeles, it's going to do the same task again, starting from the top. But because it's now filtering on Los Angeles, it will return different data. That's definitely a case where initializing multiple times is important. The function we will spend most time on is getNext. GetNext basically means, hey operator, give me a row, and the operator will respond by saying, here is your row. But in between that call and that response, something happens. And that is different for each operator. Every operator has its own task. Most of the time, that task involves calling getNext on other operators, because a lot of operators are like, hey, you want a row? Sure, but I don't have data. I need to get my data somewhere myself. So it's often one operator calling the other, and then that other operator first having to call yet another operator just so it can do its work. The third function, close, is really irrelevant for most of us most of the time. It's there. It prevents memory leaks. I'm happy it's there. I have never had to look at it. And I have done more than 10 years of work with execution plans. So you probably will never have to look at the close function either. But it's there. The term operator is unfortunately an overloaded term. It has two different but related meanings, which can be confusing. First, we use the term operator to denote a specific class, a generic type of operator. The quote on your screen is taken from the execution plan reference, so it's more focused on correctness than on ease of reading. But the simplified version of that quote is, the filter operator reads a row, does a test, and then either returns that row or does not return it. That's what the filter operator does. But when I talk about the filter operator in this way, I'm talking about the generic type of operator, not about one specific instance in an execution plan. However, a coworker might approach me, ask me to look at the screen and point at an execution plan and say, hey, there's a filter operator there, there's a filter operator there, and there's one here. Looking at my query, I understand this one, I understand this one, but the one here has me puzzled. I don't understand why it's there, I don't understand what it does, and it concerns me. And then I might look into that and try to help that coworker understand. He talked about 3 filter operators. Those are all different instances of the same class. In both cases, we use the term operator. We don't have different terms for the class and the instance. Most of the time, the context makes it clear what we mean. Sometimes it's confusing. Now we have talked about operators. Let's also talk about the arrows, the data flows. They are not actual elements of the plan, but they are still there. We see them on the screen and they have a relevance because they represent which operator, and we're talking about instances here, not the class, call which other operator. So if you look at an execution plan, you will see that every time, always, is simply a basic rule of how execution plans work. Every operator is called by exactly one other operator, and it returns rows to that exactly one other operator. And a bit of terminology here. If we have such a relationship between 2 operators, the one that is calling the other is called the parent, and the one that's being called is called the child. So the parent calls the child, and the child returns rows to the parent. Looking at the relationship from the other side, so from the parent to the child, it's not always one. Some operators do not call other operators. Many operators call exactly one child operator, but there are also operators that call more than one child operators. The structure of every child having exactly one parent and every parent having 0, 1 or more children is called a tree in mathematical graph theory. And there is some terminology in execution plan that comes from graph theory, like for instance the term nodes. You sometimes see the term node, and a node is an operator within a plan. So the node is actually always the instance of an operator and never a class. But most of the time we use the term operator, but sometimes you will see the term node. Now with that basics out of the way, let's go through a few common misunderstandings. One of them is the cost percentages. When you look at execution plans, Microsoft gives you some percentages that look very easy and very handy to quickly look at. You may already have seen them, you may not. Let's look at them, and let's then also talk about why I call this a misunderstanding. So again, the example is silly. This is not representative for what you ever should do in your real code. But let's assume that this is a slow query and I needed to fix this. And this is my first attempt, or my second, or my third, or whatever. It's an attempt to make it faster. And what I can do is select an entire batch of the 2 statements. And it's actually 3 statements because this declare is also a statement, but not because the declare is a statement, because there's an assignment here. So I will get 3 execution plans in this case when I look at the execution plan only. The first one is for the assignment. I'm going to ignore that and I'm going to scroll up. And let's move the bar a bit. Now we see both execution plans on the screen. And I'm going to zoom in a bit and I'm going to show you the first one has 99%. And I messed up at zooming so you don't see the text. I will change that later. The second one has 1%. And if I zoom out again, you will see that that is the query cost relative to the batch. So the query that was given to me as a slow query costed 99% of the 2 combined. And the second one that I made faster was only 1% of the total cost. I made it 100 times faster. I'm a query tuning god. I am awesome. Praise me. Pray to me. Sing my... You get the picture. Let's not overdo it. Now, sometimes when I go like this, there are people who say, yeah, but Microsoft calls it an estimated execution plan. Who knows, the actual execution plan might be different. Well, I already told you that's not the case. But let's bear with those non-believers and give them what they want to see. Let's look at the actual execution plan, or the execution plan plus runtime statistics. Let's run the 2 queries, and these 2 are pretty fast. And let's look at the execution plans, and hey, now we have execution plan plus runtime statistics, the so-called actual execution plan. And look, the first one still 99%. Second, just 1%. I am a query tuning god. I am awesome. There is no denying it anymore. Well, wait. One more test before I actually start to demand a raise from my boss. Let's look at the query set statistics IO on a set statistics time on. So I'm going to enable those options. I'm going to disable the execution plan because on a query this fast, that actually has too much overhead and it makes the statistics IO on time less reliable. So I'm just going to run the queries now and look for the statistics IO and statistics time. That result is here. And let's zoom in again. The first query, 24 milliseconds, 689 logical reads. That was too slow. And I made it 100 times faster. So now it took, what? 28. And it did almost 100,000 logical reads. That's not 100 times faster. That's a lot slower. And way more resources used. I absolutely made a mess out of this. I made it much, much worse. I'm not a query tuning god. I'm a query tuning devil. But SQL Server is my complicit. Because even if I keep these options enabled, I enable the execution plan again. So we still see those, and now you see how how different the elapsed times are. That's why I don't do it normally. But you see the same logical reads. So here SQL Server tells us the second query was much faster, was much slower and much more expensive. Looking at the execution plan, it says it's 1%. How can I align those two? Well, Let's hover my mouse here. I'm going to zoom in again. What I see here is a number called the estimated subtree cost and 0.584. Keep that number in mind. I also look here and I see the same value, estimated subtree cost, but now the value is 0.0065. Trust me, I verified the math. That's 1% and 99% if you add two together. But it's called the estimated subtree cost. Estimated. Can I stress it enough that it's estimated? Do I need to draw more lines? It's estimated. It's not an actual cost. Now here's the thing. If you work with slow queries, very often the reason your query is slow is that there is an issue with the estimates. SQL Server tries to predict how many rows there will be, but sometimes that prediction fails. And then it compiles an execution plan based on an incorrect assumption of the number of rows. The estimated cost is computed based on that wrong assumption. And now you are going to use that number to tune the query, even though that number is the reason you got the wrong query. That is never going to work. And here's the thing. Let's return to the, whoops, that was the wrong button. Let's return to just the problem query and just look at the execution plan only. Given what we now know about this query cost relative to the batch, what do we think we should hold of this cost that so many people look at? I see so many people look at an execution plan and say, oh, this operator costs 93%. That's where the problems are. This number is also based on an estimated operator cost. If the number of rows is estimated incorrectly, then this number is incorrect. This number might be so wrong that that is the whole reason the query is slow, and you are going to look at that to determine what the issue is. You are wasting your time. You are wasting your boss's money. Don't do that. So, cost percentages. Oh, they are so deceptively easy, but very often they are just deceptive. Don't let yourself be fooled. They're always based on the estimated cost, even if you have the actual runtime statistics, because there is no actual cost. If your estimated row count is wrong, then your estimated cost will always be wrong. And even if your estimated row count is correct, the estimated cost can still be off because it's a number computed by a formula that is based on assumptions about your hardware. Assumptions about how much memory you have, how fast your drives are, it's how many other users there are. Those assumptions are probably not exactly correct for your system because they are fixed, hard-coded assumptions. They are also often incorrect. So I'm not saying that you should never look at them. They have a value, but be aware of what you are looking at. You are looking at a number that is computed based on an estimated row count, which we haven't even verified yet whether it's correct, and based on hardware assumptions that are not documented, so we cannot even verify whether they are correct. Yes, there are cases where it makes sense to look at a higher or lower number there as a basic starting point, but please do at least verify the row count first. Because if your estimated row count is wrong, it's a completely useless metric. The next common misunderstanding is the redirection. When I do this live, I do a show of hands. For virtual, we can't do that. But the internet is completely overflowing with people saying execution plans should always be read right to left. And that is also wrong. And that is misleading, and you should not believe that. To understand how you should actually read execution plans, let's run through a simple demo of how an execution plan actually works, what happens when we start executing the query. So we have an execution plan on screen, and let's assume that we run this query. Now the select operator is not a real operator. The select operator represents the client. So the client says, I need a row, and that request goes to the filter operator. Get next. And the filter is the operator type that says, hey, I would love to give you a row, but I need data first. So, hey, table scan, give me a row. Table scan can look at actual data in your table. So it will scan a table, it will find a row, and it will return it to the filter operator saying, hey, here's a row. Enjoy. The filter operator has one specific task, and that is to ask for a row and then look at it and do a certain test. Which test depends on some properties, but it does a specific test. It looks at the row, and in this case, it looks at the row and says, no, I don't like this row. I'm going to discard it. Hey, table scan, give me the next row. Table scan will go like, sure, here's your next row. Enjoy. The filter will once more look at the row, look at the test it has to do, and it will say, oh, this is a beautiful row. I love it. My parent operator will love it. Hey, select, here's your row. And then, of course, this process repeats because probably the client program wants the next row. Now, if you look at your screen, the red arrows, and for the colorblind people, those are the arrows flowing left to right, marked get next, those represent the flow of control. The blue arrows with no text underneath and right to left, those represent how data flows. So we have two directions here. We have the flow of control direction and we have the flow of data direction. In complex execution plans, following the data is often a very good way. Like police officers follow the money, we follow the data. So very often it is correct that we start at the right side and follow the data, but only very often and not always. And we need to be aware that flow of control is different. There may be operators somewhere in the execution plan that do a test to determine whether to call that child operator at all. Imagine an entire Christmas tree of operators, 10 or 20 or 30 of operators, and you have analyzed them all and followed the data, and then you come to an operator and you see that that operator said, oh, I don't need my entire subtree, I'm not going to execute it. So you just spent 2 hours analyzing operators that didn't execute at all, that are in the plan for specific cases, but not for your case. That's a waste of time. And why did that happen? Because you started at the right and didn't realize that the flow of control starts at the left. So you have to do left to right and right to left and inside to outside and outside to inside and start at suspect areas. There's no fixed direction. And especially in large execution plans, you often start at a suspect area. Are there any questions so far? I assume that means a no, especially because I already said that I could just be interrupted for questions. So I'll continue. Now, we have gone through the basics of how to read them, and especially how not to read them, but also how to read them. Let's go to the properties, because there is a thing in execution plan called properties, and you don't see them, but it's like an iceberg. Most of the valuable stuff is beneath the surface. In an execution plan, the tip of the iceberg is what you see in the graphical execution plan. But the true wealth, all the good stuff, is in the properties that are hidden beneath the surface. Let's look at the demo to understand how this works. So here we have a batch with 2 different execution plans. If I just ask the execution plan only to ask SQL Server, how are you going to execute this? You see 2 identical pictures. Both of the pictures for the first and the second look the same. There is no difference. If you execute the 2 queries, you will see 2 different result sets. The number of columns is different and the number of rows is different. The first one, you see that all the rows are returned. And the second, you see that many rows are skipped. Makes sense if you look at the query. But here's the thing, the execution engine doesn't look at the query. The execution engine looks at the execution plan. And these 2 execution plans look the same. How can they produce different results? Well, because they only look the same. They are not really the same. If I hover my mouse here over the clustered index scan operator, let's start with this one, that's easier. If I hover my mouse over this clustered index scan operator in the second query, and I will zoom in again, you will see a property called output list. And that property has a list of the 5 columns that we listed in the select statement for this query. So that's why this operator knows I should only return those 5 columns. And we also see a predicate property, which has, it's worded very confusing. Execution plans love to add lots of fluff and needless database names and brackets to make your life harder. But once you cut through that, you will see that effectively this says modified date is larger than or equal to the 1st of January 2013. And that's exactly what we had in the where clause of the first query. So these two properties combined ensure that for this second execution plan, only these 5 columns are returned and only these rows are returned. Yes?
Yes, there's a question in the comments.
Yeah.
Says, if you want to start with a suspect area, but you cannot use the percentage to identify these suspect areas, how do you identify them?
Experience. It's a very short answer. It's very blunt, but that's the only answer. Also, this is a case where it is okay to use the percentages as long as you're aware what you're using. Do check that the estimates are correct. Often they are not. The estimated row counts, I mean. And I am talking about properties. Now, in the properties, there are some properties that can help you see whether or not the number of rows was correct or not. I'll highlight them in the demo. New version of SQL Server even put them directly on the screen. That's here. But older versions, you need to look at the properties, and then you will see the number. Always need to find it. The estimated number of rows and the actual number of rows. So these two values. This is what we estimated to be returned by this operator. And this is in the runtime statistics what was actually returned. In this case, they're fairly close. That means that in this case, those percentages are fairly reliable. We still have the hardware assumptions, of course, but they're fairly reliable and they can give a good starting point. If this number here, let's erase the stuff again. If this number here had been 10 and this number had been 2 million, and this number here, this 100% here would be used as well. In this case, it's one operator, is the entire plan, so 100% is always correct, but you get my drift. So if there's a huge mismatch between actual number of rows and estimated number of rows, then that is probably your issue and you should fix it. If they are close enough, then those percentages can be a good starting point, but don't trust them blindly. That's basically what I was saying. I hope that answers the question. So I went through in the output list and the predicate properties to understand why the first query only returns 5 columns and only a selection of rows. The first query has a much longer output list. The formatting is terrible, and it also ends with 3 dots and ellipses to show this is not even complete. I can't fit everything on the screen. There's also no predicate. Because there's no predicate, all rows are returned, which matches the query, of course. The output list is all columns, but SQL Server actually lists them all and it doesn't fit on the screen. So what you can do in that case is right-click and go to Properties. If you have never done this before, it will open a new pane. In my case, it will only highlight the pane. That's a Properties pane here. I'm going to drag it out so you can see it. Then I'm going to put it back because I always like to have it docked. If you always leave that open, then you never have to do the right-click properties. What you can do instead is just left-click an operator. And if you watch the right part of the screen as I click in the left part, you will see that when I click somewhere, the data changes because it's always the properties of the highlighted element in the execution plan. So here in the pop-up, we saw that the output list was too long. We couldn't see everything. In the full properties list here, we can see that you can click and you can see everything. In this case, I used the plus sign to expand. You can also use the ellipsis to get it all in a separate window. So there's multiple ways to get to the data. Also, there is some stuff in this window here. These are always all the properties. What you see here is just a selection and not everything. So if you want to see everything, you always should use the properties window and not the pop-up. But the pop-up is often more convenient if it happens to contain what you want. Like I said, the subset is chosen by Microsoft. It's not always ideal. Yeah, hover over, I showed that. I did not show in the demo that you can also hover your mouse over an arrow. Now, an arrow is not even an element in the execution plan. It cannot have properties. What you see when you hover over an arrow is a subset of the properties that applies to the operator to the right. So in this case, to the right, the text is cut off, but I recognize the icon. It's a clustered index seek. And if you look at the properties of the clustered index seek, you will get a huge list. And the 5 you see when you hover over the arrow are all taken from that huge list. But this is a more convenient list for just the output produced by that operator. So it can be handy to look there. But realize when you hover over an arrow, you're not looking at the properties of the data flow. You're looking at the properties of the operator to the right side of that arrow. And like I said, right click, select properties, or leave the pane open and just click somewhere to change focus. And that gives you all the properties, not cut off in any way. Everything is there. The top left operator, the select, also has its own list of properties. And I see I'm running out of time, so I'm going to just show it very quickly. If I hover over the select, you see just a very short list, not much. But if I click the select, and I'm going to drag the properties window out one more time, you will see that actually the amount of properties here is very long. And I would love to go through some of those properties because some of them are intensely useful. They give an understanding of how the execution plan was compiled, how the query as a whole worked. They give a lot of information, and it's getting more every new version of SQL Server. I don't have time to go through that, but do that on your own when you have time. That was the demo I skipped. I did quickly. For operators, you see the properties that apply to that operator. Some of them, like the output list and the predicate, influence how the operator works. Some of them, like the actual number of rows, are information about how the operator worked, what happened. So there are different classes of properties, but they're all important. I do not have time to go through this meaning, but that's why I have this execution plan reference at sqlserverfast.com/EPR, short for execution plan reference. By now I have documented at least half of the operators, and most of the more common ones are almost all documented. So if you ever see a property and you want to know exactly what it means, just go to the execution plan reference and read it there. Now I see that I have run out of time. I predicted I would have time for one of the two examples. Actually, I have time for 0 today because I'm exactly on time now. So I have to skip this demo. I am going to tell you I plan in the near future to record this session on my own without time limits and put it on my YouTube channel. So follow me on Twitter, and I will announce on Twitter when I have a longer version available where I also run through the examples. That version will probably be 75 or 80 minutes or so, and then I will have time to go through all of that too. I promise some resources. I'm going to steal a bit of your break time. There is this book, SQL Server Execution Plans, 3rd edition, written by Grant Fritchie. Grant himself likes to say the guy who wrote the 2nd edition was an idiot. He didn't know what he was talking about. That was himself, so he's allowed to say it. Frankly, I've read the 2nd edition. I agree with him. But the 3rd edition is a million times better. It's a very good book to get you from the getting started level to the intermediate level. And it's free. You can download it as a PDF, and there's a long URL. I hate long URLs, so I created a tiny URL, Redgate exec plans, and you can download the book from there. If you prefer to have a dead free copy in your hands, you can order it from Amazon.com. Obviously, that one is not free. If you want to know lots more, I already mentioned it, a bit more self-promotion. September 8 and 9 at the Data Platform Virtual Summit 2021, I am going to do a remote virtual delivery of my training class Execution Plans in Depth, where I spent 8 hours trying to get you at as high a level as possible. And then there's the execution plan video training, again, 10% discount with the code DataGeeksSFL. valid until the end of August, or time unlimited 20% discount if you go to my training class in September or later. Pluralsight.com has also a lot of good courses on execution plans, and for detailed information that is not easy accessible but very complete and correct, hopefully, you can go to the execution plan reference. I hope I answered all the questions that were asked during this session. If you have questions later, mail me, tweet me. I will try to answer them. If you don't get an answer within a few days, I'm not deliberately ignoring you. I'm not a rude son of a you-know-what. I am just being overwhelmed. I am sloppy and I made a mistake. So just send me another mail, say, hey, I sent you an email, you didn't answer. And I will say, sorry, you're right. And I will answer, or will say, sorry, you're right. I'm a bit busy right now, but I will get back to that. I try to answer all honest questions with honest answers, but sometimes I'm a bit overwhelmed. That's all I have. I thank you for being here. I thank you for your interest. I hope I have gotten you on the path to execution plans. And I most of all hope that this weird pandemic will finally shut down, because I have been in the South Florida area once. I wouldn't mind going there again. Perhaps speak at a user group or at another Data Geek Saturday. But for now, goodbye, enjoy the rest of the day.